You're welcome to another video of the course IP version 6. In the previous section, we have already discussed two important neighbor discovery protocol messages, router solicitation and router advertisement. And in this section, we will see two other important messages, neighbor solicitation and neighbor advertisement, which have critical roles in IPv6 communication, and they handle tasks like address resolution, a replacement for address resolution protocol or ARP in IP version 6, duplicate address detection, and neighbor unreachability detection. To better understand the role of neighbor solicitation and neighbor advertisement messages, I've already prepared a topology, a simple topology just with two clients connected to each other through a switch, and they are configured with an IP address in the same subnet 2001 AA BB CC, and 1 for the interface ID of the client 1 and 2 for the interface ID of the client 2. The same as IP version 4, when client 1 to communicate with client 2 in the same subnet needs the layer 2 address of the client 2. And when client 1 want to communicate with a node outside of the subnet, must have the layer 2 address of the gateway. Client 1 to resolve the MAC address of the client 2 from the IPv6 address must use address resolution process, which is ARP protocol in IP version 4, and the replacement in IP version 6 is to send neighbor solicitation message. Through the neighbor solicitation message, client 1 can request the MAC address of client 2 with giving the IPv6 address of the client 2. And then client 2 will advertise the reply or the MAC address of itself with sending neighbor advertisement message. To better understand the format of these two messages, I've already captured these two packets, neighbor solicitation and neighbor advertisement, in this topology. And let's at first check the format of neighbor solicitation message. This is a sample neighbor solicitation packet sent from client 1 to client 2 to resolve the IPv6 address of the client 2 or find the MAC address of the client 2. As you can see, the source IPv6 address is the IPv6 address of the type of destination that we are going to resolve. Can be link local address, unique local address, or global unique address. In this example, is a global unique address. And destination IPv6 and destination MAC address are solicited node multicast address that we have already discussed in a lesson with the same topic, solicited node multicast address, in lesson 8. This is an ICMP version 6 protocol of the type of 135. And in the content of the message, you see the target address that we are going to resolve. Neighbor solicitation is not only used to resolve the IPv6 address, but also it is sent when we want to make sure that the IPv6 address is not duplicated. Also in neighbor unreachability detection. Duplicate address detection means when a client obtains an IPv6 address dynamically through the process SLAC or DHCP version 6 to make sure that the IPv6 address is not duplicate, will send a neighbor solicitation message for the same IPv6 address, and when does not receive any reply from this IPv6 address, that means that the IPv6 address is allowed to be used for the client. And when we want to make sure that a neighbor is still reachable or not. Now let's also check the format of neighbor advertisement message. This is an example of the neighbor advertisement message in reply to neighbor solicitation message that we have already checked. Neighbor advertisement message is sent unicast in reply to the neighbor solicitation message. As we know in ARP address resolution protocol, in which ARP reply is sent unicast to the sender of the ARP request packet. And in the content of ICMP version 6 with the type of 136, you can see not only the target address that we are going to resolve, you see also the link layer address of the target address. Exactly like our process in IP version 4, when a MAC address is learned, it is kept inside a table that in the next communication not required to repeat the process again to resolve the address. In IPv4, it is called the ARP table, and in IP version 6, it is called neighbor cache. As an example, in Cisco iOS routers, you can check inside of the neighbor cache using show IPv6 neighbor command. And at the moment, you see no entry inside the cache. And when we ping the IPv6 address AA, BB, CC, and then 2, and then we check again inside the table neighbor cache, you can see that the address is reachable. There are also some other states in neighbor cache, including reachable, stale, or delay. And here you can see a quick definition from each state in IPv6 neighbor cache. Incomplete, that means waiting for a response to a neighbor solicitation message, or address resolution process is still in progress. Reachable, it means the neighbor is reachable. Stale, information is still valid but has not been used recently. Require further communication to verify. Delay, neighbor has not been heard from recently. Waiting to send a probe after a short delay. And finally, probe means actively probing the neighbor with neighbor solicitation message to confirm reachability.